Use of templates is very common in networking automation. Primary value of the template for network engineers is to achieve the configuration consistency. Once appropriately implemented and properly tested, they can really improve the network operations, reduce the errors, and so the downtime. Even in NSO, use of templates is very common. I am Niraj Chandak, working in NSO core function pack team at Cisco. And today I'm going to show you golden config templates, which combines the simplicity of templates with the advantages and flexibility of NSO automation. So here is our agenda for today. We'll quickly touch base on the templates in networking, templates in NSO, and have a quick recap on the device templates. And then we'll try to answer basic questions related to golden config template, like why do we need it, what is it exactly, how to use it. So we'll have a demo with NSO, and we'll have a short demo of one use case with Cisco's Crosswork workflow manager. So what is template in a networking domain? It's like it holds predefined configuration. It's like a blueprint which can be used to set up a networking service or device. Uh, Nowadays, everyone is using AI, and I got tempted. And guess what? I asked this question to AI. It gave correct answer, which we already know. So what templates in NSO? We have service templates, which are part of NSO package and get loaded when NSO starts. So a point what I wanted to make here is, let's say if we want to make any changes in the configuration, which templates holds, it's like a part of package upgrade in NSO. And what are device templates? Device templates can be created dynamically on need, maybe from CLI, and we have an action to actually apply those device template on the onto the device. So let's have a quick recap of the device templates. Let's log in on NSO CLI. I have couple of NetSim devices which are already loaded in NSO, and net package is also loaded. I have one device template. Let me load merge it and show it to you. Commit try run. So this is the device template. It puts some BGP configuration on the router. Just to keep it simple, I have just added one variable for the neighbor IP. Let me show you the native format. So config is something like this. If I commit, the device template has been stored in the CDP. Now we have a couple of devices. Let's say I want to push that config on XR3. Just verify the config already present on the devices. I'll say devices config router. So none of the device has any BGP config. So let's apply this device template. I will go XR3 apply template. Here I'll give my template name. In variable I will give name value for this variable. Maybe I'll give IP as 10.1.10.10.1.1, and I can see the config is getting pushed on the device. This is my config going on the device XR3. Variable value is being replaced, and if I commit, the config will go on the device. Let's verify it quickly. Config router. Now let's say we want to make some changes in this config, maybe add a new route policy or update this neighbor. In such scenario, we may need to update the existing template or add a new template and again execute the action to apply that config on the device. So making changes in the template won't update this config. Just to show you a case, let's say if I try to delete this template, it has no effect on the config on the device. It will just delete the template from the CDB. So this config is not tied with the life cycle of the template. That's the point I wanted to make here. For now, I will revert this change and let device being configured as is and device template in the CDB. Let's go back to the slides again. Let's see why golden config template. Uh, this is a device. Whatever we do is to configure this device correctly. As long as it's configured correctly, works all right, everyone is happy. We have lots of such devices. We have different kinds of types of devices: load balancers, firewalls, routers, and he's our network engineer guy. He's the one who deals with these devices on the ground. So device gets shipped, he unbox it, read the manual, understand the specifications, understand the connectivity, set it up in a real lab, and then configure for a real use. So this network engineer guy is main character, real hero of our story, and obviously that's why we want to make him succeed. But let's first see the struggle of his life. We have some BJP config we wanted to apply on device. He manually tried and configured the device. Being smart guy, he automated using script, handled for different device types. Now let's say we need to update the config. Maybe existing neighbor needs to change, so he needs to delete existing config. So then for that he needs to write scripts for delete. These config updates are happening regularly across large fleet of devices, so he needs to maintain backups just in case if anything goes wrong and he couldn't fix it in a maintenance time window, he can restore the backup. But with growing config across large fleet of devices, even restoring backup needs a proper procedure in advance. With frequent changes, it's not always easy to audit. So, and network engineer must ensure the config they push on the device is both compliant and accurate. If anything goes wrong, they needs to troubleshoot, manually remediate, and it's not always easy. And for few, because of these reasons and to add simplicity, we have abstractions or orchestration layers, and generally NSO sits on few of these layers. But writing anything on these layers needs some knowledge of software development and existing orchestration architecture, and we have dedicated software developer guy for that. And these two guys won't speak a common language, so it sounds strange when I say it, but it happened with me as well. Like working on function packs, generally QA or network admins come up with their issues. uh, it's hard to even understand, and when I see the same problem on their setup or exception in the logs, I was able to fix the same issue. uh, the sentence they say sounds like English, but the brain couldn't process it. Maybe because of the networking terminology, jargons they generally speak with. So it takes time even to establish a communication between these two guys. One more point is a knowledge transfer. We have a team of network engineers. So obviously, let's say our regular guy is not there, someone else need to take care of the things. So proper documentation, knowledge transfer should be there. And we all know what happens when a new guy receives a KT and how people react to it. So overall, with it is unmanageable with growing network and configurations. So then there was an idea, like what if we could give the capabilities of NSO in the hands of these network engineers without making them learn the software development part. If we could do this, then what we will get is all of this. With NSO, they can automate from first day. They just need to use the NSO. So the learning curve is very small, and they will get all the advantages of service RFM. They can dry run before commits, backups, restores are super easy, free deletes. There are ways to remediate, check the conflicts, auditing capabilities, scheduling mechanisms, and NSO, so multi-vendor. So it's easy to manage even at a scale. So our network engineer is really excited with this, but he still has a question: what is it and how to use it? He is very serious about trying out. That's why he even grabbed a desk in a lab. So most of the network engineer knows NSO, and even if they don't, it's pretty easy to understand. NSO has bunch of packages, service packages, utilities, nets, and nets directly deals with the devices. So golden config is nothing but just another package residing on the NSO. And we need one thing from network engineers is the config, native config, which they are anyway pushing on the device. We ask them to tokenize this config. So this they may be already been tokenizing it when they use with their scripts. And now we are introducing our first model, which is golden config template. Uh, s- so it contains a name, version, type of the config, few variables, and the config. And what goes inside the config is whatever tokenized native config they are using, we ask them to paste as is in a template. And we can just load merge this template in NSO. So it's not yet going to any device, it just created in CDB. And now we are introducing our second model, which is golden config application. This is a NSO service. Here we are mapping a template to a device, and we can give the value to the variables. So whatever tokenized variables we have in the config, uh, for them we can give value in the application or a template. So variable at the application level will take precedence over the template, and as soon as we push this config, the config get pushed to the device. And the tokenization style which we have used here, using coming from the Jinja style, because we are internally using Jinja templates. And the type native, so with NSO we have configs in different types like XML, JSON. So we support all of this. So the device config can be native, C style, J style, XML, or JSON. uh, One more point over here is user can even use existing device template what they have with the golden config application. Here is a yank tree of golden config. We won't go in much details, but at higher level we have template, application, application plan, and few actions. This is a yank to payload mapping for template. We give name, version, type, config, and there are tags for easy identification and search capabilities. This is application gang to payload. We map device to the template in an application. Template could be a Jinja template or device template, and we can add a variable list. Uh, why Jinja? So it's very widely popular template engine for the network automation. I didn't know how to answer this question. Why? But then I thought maybe I'll add whatever I have came across. So when I started on this, I came across many Cisco blogs, DevNet blogs, where people are already using Jinja to push the networking configurations. Even there are non-Cisco blogs where people are using Jinja for most of the networking configurations. When I search for the normal Jinja tutorials about the loopings and all, the example which I got are related with the networking configurations. And writing Jinja is also very simple. There are online parsers available where we can just give some template values and it shows the results how config is gonna render. Let me go back to slides. Yeah. Yeah, and one table on the template comparison, what offers by service template, device template, and golden config templates. So golden config really combines both the worlds together. Like it gives the templating capabilities, simplicity, with combining advantages of NSO FastMap. Let's see golden config template in action. So here is our NSO again, and we have the same task as our network engineer to push the BJP config. So this is the BJP config which we want to push on the device. Let's first see whether this config is accepted by the device. And says net sims. Maybe I will log in on my next device XR2 config, and config is accepted by the device. So as a next step, what we want is to tokenize this config. So here is the tokenized version of that same config. So I have tokenized four variables: BGP AS number, verb, neighbor, and remote AS. So the way we ask network engineer to prepare a template is just go in the template, have name, tag, version, type of config, and paste the native config as is inside the template. And we can just load merge this golden config template. In fact, we can even create this template directly from CLI. It's very intuitive. I can go here, BJP native. It asks me for a tags. Maybe I will give pretty much same tags. Cisco day 0, maybe XR version 1 type. Here I'll select native because we have a native config. I'll give config, and now I will copy the tokenized BGP config directly in this field, and I will give, and I'll show you commit run maybe in better structure. So this is our template. I will commit the template, and the next step we want to do is create a application. So our application looks like this. We have a name, and here we are using the template name, same template which we have used just now, BJP native, uh, its version, and we are going to apply it on device XR0, and we have given value to few variables. Let me load merge, and if I do commit dry run, it tells me verb is undefined because that variable I missed to define. So even error handling is pretty useful here. I will load merge again. I'll do commit dry run, and it shows me the golden config service and the config which is going on XR0 device. If I show you in native format, it shows me the config going on the XR0 device, and variable values, tokenized variables are replaced with their values. So if I commit it, let's verify config on the device XR0 config router config is created on the device. Now let's try to achieve the same use case. We want to change the neighbor. How can we do that here? Here in our template, neighbor is defined by a variable. So if we just change the value of this variable, it should automatically take care of changing the variable. Let's see if it happens. I'll go to golden config application, XR BJP. I will give variables neighbor, and I'll give value maybe 20.20.2.2, and I will do commit dry run. It shows me what's changed in the service and corresponding change in the device configuration. So it shows me the neighbor, it's being deleted, and new neighbor, it's being added. If I show you the native format, uh, no neighbor 10.10.1.1, and a new neighbor is been added. And if I commit, new neighbor should get configured on the device. So if I show you, now device XR0 has the new neighbor. And if we delete this application, then the config on the device will get deleted automatically. So if I go golden config application, and if I show you commit dry run, so it will also delete the config from the device. I will revert it, and we also has a plan, just in case if something goes wrong from device, we display it on a plan. Golden config application plan xrbjp plan. uh, let's try to create one more service. This time use the device template which we already have in our CDB. So maybe I'll do golden config, I'll get dt app bjp, and here I'll give device as a xr1 maybe this time, and device template xr template, and variable. So here in variable, let me copy the variable which I have in device template, and if I give value 10.10.1.1, and I'll do commit dry run. Device XR1 has been configured with the same BGP config, and this time we have used device template here. So format config in native format, it's the same config, we just pushed using existing device template. If I commit, config should go on the XR1 device. Let me show you. Show full configuration, devices, device, XR1, config, router. And now if we want to change the config, change the neighbor uh, with anything new, we can achieve this just through golden config the same way we did first time. So if I just change the golden config application, I'll give device template application, I'll give a variable neighbor IP, and if I give a new value here, and if I do commit dry run out format native, I can even when we use device template, uh, we'll get all the advantages of service RFM here. So if we change the value of variable, earlier config will go away and the new config will add on. And if I commit, it will go in and I can see the configuration being changed on the device. Uh, so the template tokenization, what we have in template, that follows the Jinja styling. Uh, so here is a cool thing. Jinja templates allow some level of programming. So if user knows a bit of Python or Jinja, maybe let's say a power user, he can actually add uh, programs or coding in his template. So here is one advanced XR template, and the config inside this template is combined with the Jinja code. Uh, so at line 8 and 9, if you see, I'm setting the banner and values are coming as a service name and device net type. So when we are rendering the device templates, we are rendering the Jinja templates. That time we are injecting the service node and device node into the Jinja template. That way the entire structure under service and device nodes is available inside the template. Here just for example I use net ID, but user can take a decision depending on existing config on the device as well. And the next step, let's say instead of having multiple templates for one device type or device family, user can just have a one single template uh, with entire golden configuration, and depending on the variable value they can choose what to push on. So here let's say if routing protocol is defined and if its value is BGP config is pushed. If routing protocol is OSPF config is pushed. And if routing protocol not at all there, some default config can be pushed. User can just configure the prefix list, uh, big prefix list using some for loop uh, very easily. Like if I show you the variable here for prefix list, I have the prefix list comma separated, and user can just do write some logic for like a split and looping, and then apply this config. In short, this template I actually generated here. So when I wrote that file, I actually used it, the live parser, help of live parser, and once I get the desired output, I just added this Jinja code in my template as is. And here I have a template. Few variables are defined in a template by default, and we can override those values in the uh, application service. So let's say config router is false in the template, but in my service it's true. So the true value will override. And routing protocol is OSPF, so OSPF should configure it. Let's see this in action. So let me load merge this template. Load merge XR advance format. So this is my template. and let me just commit this template is being created, and now let me load merge my application payload. And if I do commit dry run, it shows me the application getting created, and device uh, xr0 will be configured with the banner. uh, Login banner is name of the service. uh, Other banner is NAID id. IP prefix list is being configured, and router ospf protocol has been configured, because variable routing protocol variable has a value ospf. So if I just change this variable to something else, let's say golden config application app xr advance variable, I'll give routing protocol, and if I give value to reap, and if I do commit dry run, now it should configure the reap interface. Let me show you in native format. So reap is being configured, and if I commit it, it's going on the same device xr0. Let's verify the config on the device xr0. Show full configuration device xr0 config. Now we have the existing BGP config pushed by first template, and routing protocol, prefix list and banners pushed by our advanced template. And let me just show you a delete case. If I delete this particular application, which I pushed just now, uh, app xr advanced, and if I do the commit dry run, application will delete it, and the config on the device just related with or pushed by that particular template will also get deleted. So I'll show you native format as well. So the only config pushed by xr advanced template will be deleted. So if I again go and check on the device, it just have my router configuration. Next we have is golden config with Crosswork workflow manager. So CWM sits on top of NSO and provide another level of automation and abstraction. So something like router can be onboarded, image management can be done, and then config can be pushed or deleted using golden config template. Uh, so golden config application can be created or deleted from the workflow. Another one use case could be like user wants to check the config on the device against the golden configuration which they have. So they can perform a check sync at regular interval and take a action. So if config is out of sync, they can just redeploy the golden config service. That way config will again go back in sync with the golden configuration. So here are just a flow diagram or stages in the workflow for the golden config template. Let's see the remediation workflow in action. So let's say golden config using CWM. But before showing to CWM, let me show you one thing which I missed in last demo, is to just show my packages. So I have golden config as a service package already on my NSO. And let me show you my CWM. So this is my CWM script, and I have a GC create, delete, and remediation workflow. We won't go much into this workflow code, but it has a resource which is my NSO, and if I just run this create application, I will create one service, golden config application, directly on device xr0 only, and I'll give a new set of variables, new AS number and verb. So if I just give this input payload, it's a JSON array. We can give multiple applications, so it will create all of them. And if I just run, go into the job details, and we can see it's completed. So it actually pushed the config over rest conf, and then it must have created the service in NSO and push the config on the device. So let me go to the NSO. I see a commit being performed. So let me just verify. Maybe I will check the plan. Show golden config application plan, and I have workflow XR BJP deployed. Let's quickly check the config on the device. Show full configuration. Devices, device XR0 config router, and now I have uh, this was earlier config which we applied from NSO, and this config is applied from workflow. The same way as a create, we can run a deletion workflow. I'll go in delete, and we can delete the config from the device. So I will give my delete payload. It just holds the name of the application, and if I run it, it should just delete the application from NSO, and it should then clear the config from device 2. Now interesting thing to see here is remediation or check sync. So let's say periodically user wants to perform check sync against the golden configuration. Maybe to simulate this, let me create some out of band change on the device. So what I will do is I will set something on device directly which conflicts with the existing config. So I will go in the router, BJP 200. I pushed verb, test verb. So let me go test XR. Let's change RD. What I had manual earlier. I'm just hey, I had auto value. I'll maybe set it to manual. I don't know if it's correct, but I'm just creating a out of sync behavior, and I will show you commit dry run, and I'll show you I'll commit the change. And now if we check our service, service must be out of sync. So if I go in XR BJP golden config application XR BJP check sync, uh, it's false. So let's see and try to remediate this service from our remediation workflow. If I run this workflow, I need to give the input. So remediation input is the name of the service. uh, I will just push this payload, and let's go in the job, and it has executed actually a checksync action internally, and checksync results, it must have written the false. Let me refresh it one more time. It's completed. So it must have internally redeployed the service again because checksync written false. So if we go in the workflow stages here, uh, we can see if it first checks the check sync, and internally it makes a decision either to redeploy the service or skip it if service is already in sync. uh, there is a commit performed on CLI, so I think it should have redeployed. Yeah, and now service is back in sync. Let's verify the config on device again. Oh, sorry, I set it instead of show. So show device, show full configuration devices, device XR0 config router, and we will let's verify our RD. It's set back to the auto. So this is how remediation can be done from the workflow. And so I think we have seen pretty much everything. We can push the native config, uh, we can use the CWM, and we can have the config in different formats. So let's say if user already had some config in same native config, maybe in JSON, we can use as is in template. The config in J style, we can use as is in template. The config in C style, we can use as is in template. Mm, yeah, so let's go back to slides then. So, if you have not realized, our network engineer guy is still standing in a lab. And if we zoom out a bit, he's surrounded by an habitual environment, chilling temperature, continuous noise. But now, Golden Config has helped him succeed. So, he moved back happily to his desk. And Golden Config has also helped another character of our story, with software engineer guy. Let's say if you want to make something additional to the existing configuration, he can use golden config template. Or maybe he is working on a service code, but the config device configuration is not finalized yet. So till the time configurations are finalized, he can use golden config template, and once those are finalized, then he can start writing his code. uh, Please reach out to us if you have any questions. Thank you.